So we've learned how to write cubic functions in factored form by finding the three solutions and then plugging them into this format up here. Now what we're going to do is we're going to learn how to convert them from factored form into standard form. So notice that these three tables, or two tables and graph, are the exact same as these up here. So I'm just going to copy them down right here so we have them to look at. So looking up here, my first one is just f of x equals 1, x plus 2, x minus 1, x minus 3. The middle one is f of x equals 1, x minus 7, x minus 9, x minus 12. And the graph is negative 1, x plus 2, x minus 0, x minus 1. So I just got these three from these three up here because they're the same, so I don't want to do all that work again. Now we're going to talk about how to convert these from factored form into standard form. If you think back to quadratic functions, the way that we did that is we either drew rainbows, like this, to multiply, or we did the box method. Both of those ways still work, so you have to make a choice about what way you like best. If you would like, I'll do this one with the rainbow method. I'll do this one with the box method. Okay? So looking at the rainbow method here with the distributive property, I'm just going to leave this one alone for right now. And I'm going to just look at these first two factors, these first two sets of parentheses. I'm just going to leave the x minus 3 alone. So looking at these first two, I end up with x times x is x squared. X times negative 1 is negative 1x. 2 times x is 2x. 2 times negative 1 is negative 2. And then I still have my x minus 3 out there. Then I can simplify this. So I'll rewrite everything around it. And I get x squared minus 1x plus 2x is plus 1x minus 2. And I still have my x minus 3. Now what I'm going to do is I'm going to take all three of these terms and multiply it by these two. So I'm going to take x squared and multiply it by the x and the negative 3. I'm going to take the 1x and multiply it by the x and the negative 3. And I'm going to take the negative 2 and multiply it by the x and the negative 3. So what that is going to look like is, I still have my 1 right there. I'm going to keep all this in parentheses because all of it is multiplying this 1. I'm going to do x squared times x and negative 3. So x squared times x is x cubed. X squared times negative 3 is negative 3x squared. Now I'm going to multiply the 1x by both of these. So x times x and x times negative 3. X times x is x squared. And 1x times negative 3 is negative 3x. Now I'm going to multiply the negative 2 by both of those. So negative 2 times x is negative 2x. Negative 2 times negative 3 is a positive 6. So I'm just using the distributive property and multiplying each of these three things by each of these two things. Now I can combine like terms. So I don't have any other cubic, like cubed, third degree terms, so I'm just going to keep it x to the third. I have 2 squared, negative 3x squared plus 1x squared, so that simplifies to be negative 2x squared when I combine those. I have two just plain x's, negative 3x and negative 2x, and that gives me negative 5x, and plus 6. And the last step is to take this a value and multiply it by everything in here. In this case, the a value is just 1, so it's not really going to change anything. So I am just going to leave it as x cubed minus 2x squared minus 5x plus 6, because when I multiply all of these by 1, they all stay the same. So in standard form, that's what the SF stands for down here, is standard form. it's going to be x cubed minus 2x squared minus 5x plus 6. So just to recap, I just looked at the first two and multiplied those, and then combined the middle terms to get that. Then I took these three and multiplied it by the last factor, and got that, simplified, and then multiplied everything by this 1 to get that. Now let's look at this next one. I'll use the box method. So this is with the distributive property. Now using the box method, I'm still going to take the same strategy and just look at these first two. So if I look at those first two, I end up with x minus 7, x minus 9. So that gives me x squared, negative 7x, negative 9x, and a positive 63. So those first two turn into x squared minus 9 minus 7 is minus 16x plus 63, and then I still have my x minus 12. So these two multiplied turned into this. But I still have my f of x equals 1 times all of that out front, and I still have my x minus 12 on the other side. Those haven't changed yet. Now what I'm going to do is I'm going to take this term and multiply it by this using the box method, only now instead of a 2 by 2, I'm going to have a 3 by 2 box. Do that, and that. So I have x squared, negative 16x, positive 63, x, and negative 12. So x times x squared is x cubed. X times negative 16x is negative 16x squared. X times 63 is 63x. And then I'll do the bottom. I'm going to multiply all of these top terms by this negative 12. So negative 12 times x squared is negative 12x squared. Negative 12 times negative 16 is 192, and then I have my x there. And negative 12 times 63 is negative 756. So I still have my 1 multiplying all of this, my a value there. But now I have x to the third. I can combine these two because they're both squares, and that gives me negative 28x squared. I can combine these two because they're both x's, and that gives me 63 and 192 is 255x minus 756. And when I multiply all those by this 1, it all just stays the same. So I end up with x cubed minus 28x squared plus 255x minus 756. If you would like to do it this way with the rainbows, you are more than welcome to do that. If you would like to organize your work with the boxes, you are more than welcome to do that. You have a choice now. I'm going to do this last one with the boxes, just because I think for problems like this, with this many numbers, it organizes a little bit nicer. But if you would like to do it with the rainbow distributive property method, you are welcome to do that. So I'm going to use the box method. I'm just going to multiply these two to start with. So I end up with x plus 2, x, and 0. So x times x is x squared. X times 2 is 2x. X times 0 is just 0, and 2 times 0 is just 0. So my three terms are going to end up being as a negative 1, x squared. When I combine those 2x and 0, I just get 2x. 2x plus 0 is 2x. And I'm not going to write my plus 0. So I don't need to. It's just plus 0. I'm going to do it the same way again. But because I only have two terms, because the 0 canceled out, I only need to make a 2 by 2 box again. So I have x squared and 2x, x to negative 1. From x squared plus 2x and x minus 1. So now I get x cubed. 2x times x is 2x squared. X squared times negative 1 is negative 1x squared. And 2x times negative 1 is negative 2x. So these two are going to combine. So I have my negative 1 out front. And these turn into x cubed. Negative 1x squared plus 2x squared is a plus 1x squared minus 2x. Now for my final answer, in this case, I do need to think about this a value because when I multiply it and distribute it to each of these terms inside the parentheses, it is going to change them. I'm multiplying them all by a negative 1, which means their signs are going to change. So my final answer is going to be negative x to the third power minus 1x squared plus 2x. And so you can either use the box method or you can use the distributive property to convert factored form into standard form by looking at the first two factors first and just simplifying those, and then taking that trinomial that you get and multiplying it by the last factor out here to get a cubic function in standard form.